this incredible event offered by Polimi Data Scientists, our Politecnico di Milano association. The title of the event is Computer Vision and Insurance, a concrete use case from Assicurazioni Generali. And here with us, we have Marta and Antonio from the data science team who is presenting the project. So hi to both of you. Thanks for having come to present your use case to us. So first of all, I want to assure that we are recording the meeting. So Massimiliano, can you confirm that the meeting is recording? Okay, great. So I will start just still a couple of minutes to present, which is our association, Polimi Data Scientists, and then we will go through the use case with our guests. So let's go on. What is Polimi Data Scientist? So we are a community of students and professionals who are professionals and students passionate about data science. So let's give some background to Polimi Data Scientists. It was founded around 2017, 2018 by two EIT Master School members in Polimi. Their vision is very challenging, but also exciting, because we want to complement the knowledge we are given in our university, which is a bit too much theoretical, but not too much practical, with the learnings that comes from the industry. And how we can reach that? We can reach that building a community that is willing to share between each other useful tools among the members and the community. And how can we reach that? We have several examples. And one is like the event we are hosting today. Events. The events are helpful to connect the community with professionals. And those can be either coming from the industry, from businesses whose core duties is related to data science, but also researchers. We had events whose hosts were guests are PhD students, and we're talking about their study related fields to our community in data science. Then we have much else. We have data science news. Actually, we are continuously in our community writing blog posts about machine learning techniques and tools. We also have a monthly newsletter. If you haven't subscribed to that, I invite you to do instantly. And when you can receive in your email the most exciting news related to data science fields once per month. And then there's much more else. Also practical events such as projects. What the one you see here on the right is a Kaggle Shopee competition that has just ended 2 days ago. And in our community, we provided some resources to start, also for beginners, to start looking at data and using data science for the first time, and to join in a team, the team of Polimi Data Scientists Association, and try to win the competition. So forming a team and entering into the data science field with a team, with a community. And something else to say, podcasts. Actually, we started recently to organize podcasts with guests to discuss in general about data science. And those are the two that actually have been held. AI for Cancer with Marco Varrone, our president of the association, and Data Jobs, which is, and those are a podcast held on our Telegram group. Yeah, so given said that, our association is quite small, but we have reached an important milestone. We got more than 100 members. We are very happy to that, and we looking forward also to your application, whether you didn't have it already done. So what you can expect from us is, besides having monthly newsletter, exclusive events like the ones of today, and also a job portal for having the latest news and regarding our job portal for you as data science field. So follow us. This is a QR code which actually is working. So you can put your mobile phone and get the QR to be redirected to the link of our association, explore which are the resources we offer, and maybe join us for the next event. So given saying that, I finished to share my screen and I give the word to our guests, Antonio and Marta.
Yes, thank you. So I share the screen. Let me know if you can see it. Maybe.
Yes.
Okay. So first of all, hi to everyone. And as Daniele just said, the topic of today is computer vision applications in the insurance field. And in particular, me and Antonio then will present you a use case that we are developing in Generali. So let's see the agenda. We will start with a general introduction about us and our team. Then we will bring you into our working daily world to see how an AI project is in a company like Generali. And then we will show you how a use case, a real use case project that on which we have been working for about 2 years now, yes, more or less. For motor claims with a deep dive on the vehicle panel detection model that we guess could be interesting for you. And at the end, the usual Q&A session, but in the meanwhile, if you have any kind of question, please feel free to ask us in any moment. So let's start from who we are. I go first, and I am Marta Caserio, a data scientist in the Analytics Solutions Center team in Generali, working mainly on process automation and of course on this computer vision program. Previously, I worked for a consulting company for about 3 years for customers in the insurance, but also banking, retail, energy and utilities, and banking sectors. While for talking about background, I studied mathematical engineering, but at the Politecnico of Turin and not Milan. And then I leave to Antonio for 2 words about yourself.
Hi to everyone. My name is Antonio Montuschi, and I'm also a data scientist at the Analytics Solutions Center, which is the team led by Alessandra. And yeah, I'm also one of the data scientists that are involved in this computer vision program, like Marta. And as a background, I studied control engineering at La Sapienza in Rome, and then I've encountered computer vision during my master thesis that was about object detection. So nice to meet you all.
Okay, then just to give you a bit of context of where we work. The Generali Group, for those of you that maybe don't know yet, is one of the biggest insurance company in the world that was founded in Italy, in Trieste, and that this year celebrates the 119th birthday. Maybe you saw the light show to the tower in City Life. And here below there are some numbers, but I guess the 2 most interesting for us are these 2. We have this sort of lifetime partner philosophy for our customer that is based on 4 pillars: ownership, simplification, human touch, and innovation. And so as you can see, innovation, but also simplification, that many times means digitalization, are of key importance for the company. And this computer vision program is one of many initiatives that the company somehow, on which the company invests somehow in this sense. And on the other hand, there is the global presence of Generali in 50 countries all over the world. But so you have to think like many sub companies under the same group, but we don't come from one specific and local team. We work in head office, which is Assicurazioni Generali, and so we usually have to work with many countries. So one of the main challenges that we have to face every day is to work on different markets with different data, with different also languages and so on. And in this context, in this environment, our team is the Analytics Solution Center team, which the mission is to support and to spread the adoption of the analytics and AI across all the countries of the group in different ways, from a technical advisory or knowledge sharing and knowledge management on local projects, but also with hands-on, and so design of solution and R&D activities. As you can see, our team is quite international and diverse in terms of background and experiences, since we are not just a data scientist, but we work with the business translator that help in link the business counterpart to our technical solution. So just from that, you can understand that we don't work just between data scientists, but we have to interact with many other kind of roles in the company. So let's see how looks like the process that an artificial intelligence project has to follow in our company, but let me say in each big company. So I hope that this representation is familiar for you, because I remember that when I studied at the university data mining, there was always this kind of a cycle. So for each problem, so each project, you have to understand the business case, and then you have to explore data with many nice plots and statistics, and then you have to prepare data in order to get the final table as input of the modeling phase, where you can try a lot of different algorithms and configuration. And then you evaluate all of them to choose the best one. And then, of course, you have to match results of the model with the business case in order to understand if they make sense. But if everything is okay, there is the deployment, the production. And so basically, that's it. This is the end of the project. So this seems quite let me say, a clear cycle. This is a nice story, but on the other side, we have how we currently represent all the steps of our project. So as you can see, the main steps are quite the same. So the development, the test, and the industrialization or deployment. But if we explore each one of them, we have a lot of criticalities and things to take into consideration. Starting from here, from the idea generation, because usually we don't have a clear goal from the business. We're starting from a business problem or a business need, and we have to translate these into our technical requirements. So we have to understand what we can do to help and support the business, and translating these into an algorithms, into a model and a project. And so there is also always the business understanding and the test planning, because time is always a constraint in the real world. We usually don't have enough time to do what we would like to do, but we start the project, and really first step is not the data exploration, but the data acquisition, because we have to get data from the different countries that in turn have to retrieve data somehow from their IT system. This sounds, let me say, simple, but trust me, it is not at all. So there is always this big step of data acquisition. And then again, the data exploration, the data preparation, and the modeling phase with the validation and test, as we said before. But the test phase is not just run a test on the model to collect performances, but is also performing IT integration with the IT system, performing user acceptance tests, is also handling exceptional cases, because if we think about a model that have to go into production, we have to handle any kind of scenario. So if something goes wrong with the model, we have to handle it as exception, and so we have to design it before. But if anything, everything works well in the test phase, then we go into industrialization, and so the deployment, where we have also to set up a lot of KPIs to monitor and validate continuously the model and the application. There is the involvement of the governance and management, both for data protection, because today, nowadays, is really a hot topic, the data protection, especially when we work with customer data. But we also needed to set up a continuous maintenance for an application. And then we go on with the deployment of the model, the integration with the user interface. And on top of this, we have also, let me say, make the technical solution understandable by the business, because it's the business that have find at the end of the story buy the solution and use that every day. So we have also to translate back from technical to business in order to make really tangible the result of our work. So the message is here that the process that an AI project has to follow is really a mess in terms of activities, but also in terms of maturity, evolution, and actors that are involved. So on the left side, as you can see, we have, we call it the solution life cycle, because usually we start from an exploration case or proof of concept, just to prove to the business the potential value of the solution. And we start usually with a little amount of data, with a quite closed perimeter, just to see if the things can work or not, if it's feasible or not. Then, if the results are promising, we go on with the prototype. So it's always a draft, but as you can see, we're starting thinking about the final product. And so we enlarge a bit the amount of data. We starting consider also other scenarios respect the POC. And in this case as well, if everything works well, we go on with the pilot or MVP, where as you can see, it's not the final version, but is already a donut. So basically, it's the version of a product that have enough features to be used by a user. And in this case, if all the KPIs are good enough, if the business is let me say, is aware of the value of the solution, the final step is the production with the fancy and colored donuts. That basically is the full optional product. And so this is the life story of a product from the beginning to the production. And along this life cycle, there are many actors, many people involved on the ideal table of the project, as you can see on the right. There are both the business people and technical one. As you can see, there is the product owner, the final user, the business translator, and the compliance specialist, always for the topic of data protection that I said before, that are more business. And then on the right side, that are all the technical people like us, so the data scientists, but also the data analysts, the more IT people like the data engineer, the machine learning architect, the designer for the UX and UI, the app developer, and so on. And so, as I already said before, we usually are not working just with our computer or other data scientists, but we have to interact with many different people and many different kind of roles inside the company. So this is, let me say, our working daily routine, and where is the context and the environment in which we are working every day. And if until now everything is more or less clear, let's see what is the project that we are developing. And in particular, the asset on which our project is based are images. Images that I guess, as you can see from the slide, but I guess you already know, is one of the most popular, or the most popular medium of communication today, since each year we have more than 1 trillion of images, and most of them are come from mobile phones. So just think about Instagram, social media, influencer, I don't know, food blogger, whatever you want. Everything around us is images. And a particular feature of the images is that they have a universal language. They don't require translation, respect other kind of data like text, like voice, like number of temperature degrees in a country. And if you remember, as I said before, we usually work with many countries. And so this feature is particularly important for us, because this means that we can develop a model with the data of a country, and we can reuse the same model on other countries without, as I said, rebuilt for each one of them a different and new model. So it's really something really powerful for us. So if images are what, the computer vision is how, because the computer vision or image analytics is a field of the artificial intelligence that allow us to extract information and insights from visual data that can be both images or videos, to allow faster and more efficient decision making. If we talk about images, we are talking about unstructured data. But basically, what is a digital image if it's not a simple and organized table? Well, a digital image is composed by many elements called pixels, and each of them has a numerical representation through three main channels of the three main colors that are red, green, and blue, as you can see. And so these end up in this kind of representation that is how basically a computer sees an image. And thanks to the image analytics, we can do a lot of things with images, and we can solve a lot of problems. As you can see on the right, there are plenty of possible applications that we can implement. I think that the most popular are the image classification, when we want to associate a label to an image according to its content, or the object detection, where we don't want just to classify an image, but we want to localize each classified items within the image with a bounding box, or the instance segmentation, where we classify each and every pixel, and so the final result is not a bounding box for the localization, but it's really the mask on the item. And then in the last more or less 10 years, a lot of research was done on this topic. So for this reason, there are so many and also more advanced tasks that are today possible to be implemented, like relationship detection, which is not just object detection, but also understand the relationship between the detected objects, items, or image captioning, where we want to automatically generate the caption, the description of an image, and so on. So the message is that this world is really wide, and that things are continuously improving and changing with every day new research, new discovery, new possibilities, new implementation, and so on. And the question here is how the computer vision can help or can be applied in the insurance business. So can the image analytics basically do something useful for an insurance company? Spoiler, the answer is yes. Actually, there are many applications that can be implemented along all the insurance value chain, starting from the underwriting and pricing that basically is when a policy is open and the company, let me say, propose a price to the customer. So for example, we could estimate premiums based on the picture of a vehicle or a building. It is important also for the claim prevention, just think to all the controls that the new car have in order to prevent accident, and the claim management. So when a claim happened for an insurance company, a process of management of the claim is open. And we could do a lot of things thanks to image analytics in this case. For example, assess the damage, so understand the intensity and the severity of the damage from just looking at images of the vehicle and the damage, or also detecting and looking for fraudulent partners and so on. And the last one, operations automation, which basically means improving the user satisfaction, where the user could be both the customer or an internal employee. And some example of application are the logging the selfie to avoid a lot of documentation attachment, or also the signature validation and so on. So as you can see, there are really many kinds of applications that can be, let me say, interesting for an insurance company. But in particular for our use case, we are focused on claim management. And this is why. This is because in the claim management, we already have a lot of images, because when a claim is open, the company required to the customer or to the body shop the images of the vehicle or the claim. And so you have to imagine that every year we have about 90 million of motor claims images in Generali, and that our claims operators spend half of their time in analyzing these images just to understand the price that we have to pay for that damage, or also to find or to look for fraudulent patterns. So we have the images, we are using them, but the problem here is that we don't have the right tool to make an efficient image analysis. So what we are trying to do right now in collaboration with the different countries of the group is fill the gap between the nice to have and the as is situation, designing a new solution to support the analysis of images of the claim operators. In this sense, what we are trying to create is a combination of user experience and artificial intelligence made of two key ingredients. The first one are images, because as you can see on the right, these are the current tools that our claims operator have, that are like 90s style and very data-oriented, let me say, because to assess image, you have to click on each and every image, and so you can see just one at a time. So they are really old, and just they don't support the analysis of images. While on the other hand, we are used to different tools. This is, for example, just a Google photo, but in our free time, we are used to more advanced and user-friendly support. So the idea is to, let me say, update our claim system to 2021 and make them more user-friendly and more focus-oriented to the images that are an important asset in this step of the value chain. And the second ingredient is adding superpower, that basically is artificial intelligence to boost the first ingredient, the first aspect, that is the access to data. So to images, and so to put images at the center. And the result of this mix is this tool, this product that is called the Smart Gallery. And the sense comes directly from the name. It's a gallery which is smart. So there is the feature to be a gallery, so the user, the claims operator, can easily see the images, compare them, access them, edit, and so on, boosted by artificial intelligence insight that can help read a lot of information from images in order to make faster and also more effective and easier the analysis for the claim operator. But as you can see, we have a little demo because we think that it could be more effective that heard my explanation, basically. As you can see, this is a mock-up. It's not the final product because we are still working on it and we are creating it. But basically, as you can see, you have a gallery, so you can access images. It's quite, simple to use, very user-friendly. And here you starting have the AI components. So you have a lot of filters. Here, for example, are the controls that you can perform thanks to our model. Here you can filter from the view of the car. That seems quite simple, but basically this is the output of one of our model. Here there is the same filter for the car parts. That is something that we will see in details later. We will have an overview of the highlights from the models for each of the claims. And if we access one of them, as you can see, we have an overview for each one with all the output and the controls that we can perform thanks to image analytics. And so, for example, here we can check if the license plate that they give us as metadata is the same that we read on images. And the same, for example, of brand, we can check that the logo on the car is consistent with the data. We can, for example, here use the metadata beside the file of the image to get the geolocalization, and that we can perform a lot of other controls. For example, just look if we already have a damage in the system. That, for example, can be quite impossible for a human to go in the history of a vehicle and look each and every image to see if he already see those damage. And okay, just to give the last example, to check if an image is genuine or, for example, come from the internet, and so on. So then there are a lot of things. As you can see, it's a full application. There are notifications and so on. But now for our, it's not so interesting for us right now. But as you can see, we are really trying to create a really complete and full product and that correspond to a complex use case. In fact, now we saw the product, okay? So the box that has two main components. On one side, there is the front end. So how the user can access the output of our model. That is a long path. So starting from the interviews to the final user, then to understand, to translate them into the requirements. And our role as data scientists is that is to understand what is feasible and what is not, and then end up with the mock-up of the solution and so on. And on the dark side of the moon, there is the backend. In this case, our role is that, of course, to develop the models, but also to build this logical workflow that basically means build a pipeline where all the models, as you can see here, we have, let me say, simplified and a bit higher version of the pipeline, but our aim is to make all the models interact one to each other and to get the final result and to enable all these all the features that are decided to be put in the front end. And so this is let me say, in charge of mainly on the data scientists, but we have also to interact for the physical architecture to more IT roles, just to make our computer vision model, our pipeline of ETL, talking with the front end, with the database, with all the other system around. And so here the goal is that our work is not just develop a model, but build a complete use case is something not easy, and that required the contribution of the data scientists really from the beginning to the end in each and every step. But now I leave the stage to Antonio that will tell us the story of one of these models, so a part of that complex pipeline that I show you just now.
Yeah, maybe before moving to the next part, do you have any question up to now?
Of course.
Just to see.
Otherwise, we can go on.
Oh, I have maybe a question, more about curiosity. I thought about the 50% of time saved by this claim project you're having. This time is somehow measured in some way, or is just an estimation?
No, we performed last year in the piloting phase, just a test also on, okay, of course it's not so precise with the clock near the claim operator, but it's something that we measure during a pilot test. So comparing half of the team of the claim operator working with the smart gallery and the other half working without the smart gallery on the same claims, and looking at the time that they need to process all the images and all the cases. And so we end up with this number.
Okay, I think actually it is a very good motivator that leverages the need for this kind of use case, that even complex actually provides with great cost saving if you think about the time spent saved by this. So it actually is a very important KPI when you need to push this kind of models to business. So it was very interesting to see that.
Yes, also because productivity, it's a very important KPI in that step of the value chain. So a per 4.5 faster process is something quite impacting.
That's true. Okay, thank you. And don't want to interrupt any further.
Up to you.
Okay, thank you, Marta. So, what you have seen up to now is just the tip of the iceberg. And yeah, because behind such kind of application, there are a lot of different components that are working together in order to provide to the final user the experience that Marta was showing you so far. So what we would like to do is to give you some more information about what is actually happening under the surface. So everything that the final user is not able to see. And in particular, what we would like to do is to focus on what we call the AI engine. So the place in which our models are working, analyzing the images in order to provide all the insights for the final user. So as you probably have understood, in the Smart Gallery, we have a lot of different functionalities. We can count 15 of them, and all that functionalities are powered by more than 20 image analytics models. Now, these image analytics models are organized in a pretty complex pipeline that Marta was talking about before. And each image before going to the smart gallery is passed through the entire pipeline in order to be analyzed, in order to extract all the information that are needed in order to provide insight, alerts, and so on and so forth. Now, in this kind of scenario, a really important thing is that we need to guarantee that each model has really high performances, because if we have a cascade of models in which the second one needs the input from the first one, and the first one is not good enough, well, we are going to have some problems. So in this context, we really need really high performances of each one of the components in our pipeline. So going to the next slide, as Marta was saying before, this is just a graphical representation, okay, of our pipeline. We cannot disclose it, but the objective is to let you understand that we have a lot of different models that are running and contribute to the final output. We have image classification model, we have OCR, we are performing object detection and instance segmentation, lots of post-processing of the output of these kind of models. And all these will contribute to the final result that was shown before. Now, in the next more or less half an hour, what I would like to do is a deep dive on one of these models, the vehicle panel detection model. This model has the role of identifying the different panels of a vehicle inside an image. This is an instance segmentation task. So what we would like to do is to recognize which is a subset of the pixels that refers to a specific panel in the car. So if we go to the next slide, I would like to take a moment just to better frame the problem, because maybe some of you are not familiar with instance segmentation tasks. Now, here the first point is to understand the problem and the context. We have a car and we would like to understand which are the pixels that are referring to a specific panel. For panel, we mean the wheels, the front door, the hood, the bumper, and stuff like that. Now, the first question is, how many panels do we have on a car? Okay, we have really a lot of them, okay? If we would like to be really, really precise in identifying each single component of the car, we have really tons of different panels. And that means that we needed to make a sort of choice on what we would like to detect and what we would like to leave out. As in every project, we need to make a design choice in simplifying the problem enough in order to be tackled by the state-of-the-art technology, but we need also to keep in mind which is the actual business need and the task that we would like to perform. So in this scenario, and specifically for instance segmentation tasks, if we go to the next slide, we have an example of the annotation of a panel. Now, first of all, we are talking about supervised learning models. So we need to give a data set to our neural network, and the neural network will learn how to predict the information that was sent in the training set. So for instance segmentation task, what we would like to achieve is to identify which are the pixels inside a specific region. So we can identify this region, for example, with a polygon. So identifying the coordinates of every single corner in our polygon, we are able to have a compact and light representation of which is the area that we would like to find exactly inside the image. Now, as I was saying before, we need to make some sort of designing choice. And in the next slide, I would like to show you which is the actual choice that we made. As you can see, we have a certain degree of simplification here, because, for example, just looking at the wheel, we have the tire, we have the rim, and we have also the brakes that are all included in one single panel, okay? And we made that kind of choice because of the performances of the models that we are using, but also because, as you can imagine, build such kind of data set is really, really, really expensive. So we had to look for a sort of trade-off between the possibility to be enough precise in describing the vehicle and the time and the effort that we need to put in order to build such kind of data set. At the end of the day, we decided to use these 16 panels that are going to be the ground truth that we are using for our neural network in identifying the different panels. So now what we would like to do is just give you some hands-on demo on that specific task. So I will try to share my screen. Okay. Are you able to see?
Yes.
Okay. Because I don't have the green. You're seeing correctly the
notebook.
The notebook. Okay, fine. Okay, so I would like to cover some point with you. Okay, this is don't want to be an how-to tutorial or a lecture. I just want to give you some bit of information that maybe in the future can be helpful for your projects. So, first of all, talking about a data set, it's clear that if we have to manage a certain degree of complexity in the data set, we need a standard. We need a standard because if me and Marta are working on the same data set, we need to build something that is consistent and that can be used together. So first of all, we need to choose a standard, and the standard that we decide to use is the COCO one. So COCO is a very famous data set, which means common object in context, which provides a structure to describe instance segmentation tasks for all the possible domain. So what I would like to do is to give you some information about this dataset because it can be pretty useful. First of all, this dataset is stored in a JSON format, so it is really easy to be loaded and used and shared between different persons. And in particular, what if we look inside this JSON, the structure that we found is the following. We have different keys in which each keys represent a list of information. The most important are the images, obviously, the annotations, and the categories or classes. Now, if we look inside the images, this dataset code the single image in that way. So we have the name of the file that have been annotated, and we also have an image ID, which refers exactly to to that image. Now, if we look at an annotation, we are able to link this annotation to the single image thanks to the image ID. Okay, so these two information are linked one to the other. And as we were seeing before on the slide, we have here the different points that describe the polygon around the object. And also we have the ID of the category. As I was saying, we also have the categories, which is a list with that structure in which we have the so-called super category, which includes different classes. And then we have the name of the specific class. Also in this case, we have an ID so that it is possible to link together the information in these three different lists. Now, if we look inside this dataset, here what I would like to show you is that if we use this kind of standard, it is pretty easy to go through all the annotation and to make sanity check, see if something went wrong during the dataset preparation and so on and so forth. So if we examine the JSON, we are able to see which are all the different categories. In this case, are 80 different categories, and also the super categories. So selecting one of them, here for example, we have airplane, we are able to retrieve all the images that contains that specific category. Moreover, we are also able to visualize the image and also visualize the annotation. So we can see the segmentation around the object. Now, this is pretty cool. I think it is also pretty easy to be visualized and used. But now the question is, how can we build such kind of annotation? Because we need a way to define all that all that points, to build polygons, save it, and connect the annotation with the image, and so on and so forth. So in this case, we used an annotation tool that is called Coco Annotator. This is a web-based image annotation tool. This is open source. You can just Google it and you will find the GitHub on which you can simply download the Docker and run it on your machine. And this tool, I think, is pretty useful because it gives you all the tools you need to work on such kind of problems. So let me just give you a look on that. Here we have the front end of Coco Annotator, in which we can manage different data sets. In this case, we have just the one that I've prepared for today. We can manage all the classes that we would like to use in our data set. We have also an admin panel. So on this tool, it is possible to work as a team. So we can work together on the same data set, having visibility of the job of our colleagues. And last but not least, it also gives you an API interface, which is pretty useful if you are working on large-scale projects. Now, coming back to the dataset. Okay, here I can see all the images that I've uploaded to my tool, and what I can do here is just open an image, and then I can put the different annotation. This is really simple because I can zoom in and zoom out. I can, let's say that I would like to make a new annotation for the wheels. I select my polygon tool, and I can just make the annotation for the wheel. Excuse me a second. Okay. Now I'm making this annotation not just because I think that is fun, because it's not fun, but because I would like you to understand that in order to make all the annotation for a single vehicle, you need to spend really, really a lot of time. Okay, so this is something that is really expensive, and you have to keep it in mind when you are dealing with such kind of problems. By the way, thanks to this tool, we can define all the annotation for our vehicle, and then we can simply move to the next image and reiterate the process. Now, this when this process is finished, I just click on Export Coco, and I have my JSON that is really ready to be downloaded and imported for the project. So
Antonio, sorry to interrupt you. We received a question from Francesco Longi. I read it to you because I think you didn't see the chat. So did you make all the annotations on your own, or did you use a cross-sourcing approach, or have you thought about using it?
We have thought about using this kind of approach, but we did all the annotation by our own, because as you have noticed, those are fake images, okay? The real images that we are using as privacy constraints. So it is not possible to show that data to other people that are outside of our organization. So we had to do it all by hand, by our own. Not just me and Marta, even other colleagues, but yeah.
Okay. You have a lot of patience. Then the answer's back. And how many pictures did you annotate? And also a question, how many pictures, you annotate to make the model work correct?
Okay, up to now we are more or less at 500 images. Okay, not that much, but really in these days we have on another virtual machine the other Coco annotator in which we are annotating more and more cars. So we are almost at the double. Okay, so here the point is with couple of hundred of images, you can at least understand if your design choice is correct or not. Because otherwise, our bosses will not be pretty happy about that. So we need to be pretty sure, and we decide to take a step-by-step approach, starting from simple, annotating a couple of images, make some experiment, then we double the number of images, we made some other experiments, and so on and so forth. Once we were sure about the design choices, then we started to annotate it massively. Hope that this answers the question.
Yes. Okay, he thanks you. Okay.
You're welcome. Now, said that, we have created our JSON and is ready to be exported. Now we can just go back to our notebook, import our JSON, and look at the annotations. Okay, and it seems that everything is correct here. Once we have the data, we are ready to make some other kind of choices about the neural network, and then we are ready to make the training. So the point is, which model, which network architecture we need to use in order to fulfill this kind of task? Well, the choice was for the so-called mask RCNN. I'm not sure that everybody knows this kind of model. Let me just give you some hint about that. This model takes as input an image and provide as output three things: the class of the object, the bounding box that includes the object, and the mask that describe the shape of the object. Okay, so at the input we have the image. Then the image is passed in this first stage through the so-called backbone, which is a set of convolutional layers that are going to extract the features describing the image content. Then these features are used in order to propose patches of the image in which we have the highest probability of finding the specific object that we are looking for, and all that information are used by the mask CNN block, which is going to provide these three different outputs. If some of you is familiar with object detection tasks, this is essentially the faster CNN with an additional stream for the computation of the mask. So we have a proposal of the part of the image containing an object. Then the features are used in order to predict class, box, and the final mask. Now, this kind of architecture is pretty complex, and usually we don't build everything from scratch, but instead we use libraries that already provides this kind of implementation. In particular, we use Detectron2, which is a library from Facebook AI, which is built on PyTorch, which implements and provides state-of-the-art detection algorithm of different kinds. So we can see here that we are able to apply instance segmentation, we can apply object detection, we can apply key points estimation in order to estimate the skeleton of a human body, for example. And this is a really, really powerful tool. Just to make you a quick example, just with some lines of imports and selecting an image, which is this one, and providing a config file on which the only thing that we need to adjust are the network architecture, where we can find the weight of the network and the threshold that we would like to apply. Just with this, we are able to make a pretty good detection. And this is free and this is available. So if you are interested in this kind of task, I suggest you to start from Detectron2, which is even pretty easy to be used. But let's see how to use Detectron2 for our task. So panel detection task. Here, and this is also to show you that if we use tools that are already available and provided by the open source community, our life is easier. So we have the JSON. So let's just register our dataset. One is for training and one is for validation, of course. And then we can also inspect the dataset, for example, just looking inside one of the annotated images. And then we are ready to train. We just need to provide the configuration file that we were talking before, in which, if you want, you have hundreds of different parameters with which you can play around. But if you just want to start simple, you just need to say how many classes do you have and how many iteration, how many iteration you want to perform. And in that way, the model is ready. Now, you need to create this object, which is called trainer, and just train, let the train itself. Okay, now I will not perform this step because it takes 8 hours to perform a complete cycle of training on this training set. What I would like to show you is another tool which is pretty useful that helps you in tracking the performances of the model during all the training cycle. And this tool is called TensorBoard. TensorBoard is a tool that can read the logs of our training and provide you in real time all the metrics that you have extracted. Now, for example, looking at the total loss, which is one of the most common one, we can come here and just look at the evolution of our loss. Now, here, these 2 peaks are because I just interrupt the training and make some adjustment on the layer. I'm freezing some layer. But here, as the iteration goes, you will see that the graph is continuing. So you are able to see what your model is actually doing, even if the training is in run. But this is just one of the things that you may want to see. You can look, for example, at the performances that you're having, how on the validation set, how the performances are evolving, or stuff like that. So even this is a pretty useful tool when you're dealing with neural networks. So keep it in mind, just a suggestion. Then once the training is completed, we are ready to make some visual inspection of the result of the model. So importing, we can just import the model, create this object with the predictor. It will take some seconds because this is a pretty large and heavy model, but hopefully it will be able to do that. And then what we are going to do is just to load a picture and run and pass it through the network in order to see which are the results. Okay, it is ready. Let's start with this one, okay? We have a damage, okay, here we have different panels, so let's see what happens. The prediction is pretty fast, and then we can see the result. Okay, so as you can see, the network is pretty able to identify the wheel, the bumper, the front lamp. Here we have the fender, the rocker, and the front door. Now here, if we want to be, the hood is not checked, but consider that for our purposes, the really important thing is that the panels that are in the center of the image, which are really the subject of the image, need to be identified. So if we want to look more in depth about the different prediction of the model, we can just go through all the output dictionary and look for the different masks. Those are pretty important because if we want to just extract the subset of pixels, this is exactly what we need in order to identify which is the subset of the image of our interest. Now, really briefly, I would like to show you some concrete example. Now I'm loading a second model that I will show you in a second. Typically, an image is presented in that way, in which we have the car, but we have also a lot of noise around the car. So if we want really our model to be precise and accurate, we need to clear all the noise that we have in the background. So the models that I've loaded is exactly for that. This is a car detection model in which we are able to detect the car. And then we are able to extract just the subset of the image with the car. Now, running our segmentation model on that image can guarantee us the good performances in order to rely on that kind of outputs for our tasks. Another important thing is that if I took a second image, and then I will just stop this one, okay? Because in this case, in which we have other cars in the background, if we simply run our model, yeah, we may have too much noise, okay? Because those are panels, but we just want the panels of the car that is the subject of the image. So in this case, we see that applying a cascade of models is something that is really powerful, because in this way we can identify all the cars in our image. We can understand which is the subset, the bounding box with the subject of the photo, and then run the model on that sub image, the crop of the image. And as you can see, the contours are not really precise, but I can guarantee you that this is enough for understanding, for example, which are the panels that are involved in an accident, for example. So this is exactly what we need in order to run the smart gallery that we were seeing so far. Now, a last point, and then I will stop running the notebook, is about the hardware. These kind of models are really heavy and needs specialized hardware in order to be run. In particular, we need GPUs, as you probably know. And in order to run at this speed, these kind of models, we are using a Tesla P100, which is a pretty big GPUs. But consider that in making this kind of detection with a CPU in cloud takes something like 10 seconds. Using a GPU is 0.1 seconds per image. So the difference is really, really huge. Now, said that, let me just go back to our slide and close what we were talking. Now, we would like to give you some main takeaways from this. The first one is about the constraints. We need to be constantly aware about constraint, both in terms of time and in terms of budget, because we are working in a company, and we need to keep in mind that while working on a specific project, and this can be a key ingredient for the success of a project. Another important point is the business context. As a data scientist, we are the point of connection between different stakeholders, different professionals, and we need to ensure that we are able to communicate to the other, which is our job, which is our point of view, and we need to be able to put everything together in order to really maximize the probability of a success of a single project. And another main takeaway is about the design, because you have to keep in mind that in most of the cases, you don't have how-to guides, and you need to really leverage your problem-solving capabilities in order to solve problems that, sometimes nobody has seen before you. Another important point is about tools, because we typically don't build everything from scratch, but we are leveraging the work of colleagues or of the open source community. So first of all, look for tools that already exist, and if possible, obviously contribute. Last but not least is about team working. Data science is not a one-man show, okay? You need to work with your colleagues, you need to be able, you need to work in team. It's team working, and is something that is not easy to be built, but with commitment, you can really do that. And I can guarantee you that this is probably the most important, the most important point in this list for the success of a data scientist project from our point of view. Now, said that, I would like to thank you. Here we have some references if you are interested in deep diving in something that we have shared with you. So thank you. Feel free to contact us. And if you have any question, we are here to answer.
Thank you so much, Antonio, both Antonio and Marta. Really enjoyed this presentation, and also talking to the students and the audience here. You have seen a project, data science project, how it's like in a big group such as Generali. So now you really know what it's like doing data science in such environment. It's not that easy as doing in a Kaggle competition. So you need to label your data, spend time, but at the end you are making value and you're delivering value. So this is also very important, and we understood during the first part with Marta. So before going to the Q&A session, I wanted to also thank one person, which is actually here, and it was my point of contact for having this event, made possible this event for our association. So Alessandra Chiuderi is actually the leading the team, the image analytics team in Generali, together with some others. And I would like to thank you a lot for making me contact with the team and making this possible. And if you want to say something, also, I know that there can be some open position as data scientists and engineering. So you for sure know better than me.
Well, hi everybody. Yes, it was a pleasure for me to host this event. I think I know I should not say so, but I think it's very well deserved. Marta and Antonio did a fantastic job in putting together the presentation. I hope you enjoyed it, because it was done amongst all the other things that they are already doing. So very well done. I hope you took all the information you could get. And my suggestion is, please don't be shy and ask questions now or in the future. As far as usually you know probably already, but let's say if not, you will learn. The data science community is quite open in exchanging information, and definitely my team falls in this area. As far as the data science position opened, I honestly hope not, because otherwise it means that somebody in my team is going to resign. But there are always opportunities in the group, in the sense that there are teams, not in my team currently, as I said, we are complete, but across the group there are always researchers for data scientists, data engineers, business analytics translators, and so on, even in Generali Italia, who is based in Italy, and in the other companies of the group. So if you are interested, I'm sure that in LinkedIn there are open positions are advertised in LinkedIn, but if not, you can refer to me or to Antonio or whoever else, and we can try to understand if there are open positions across the group. Across the group might mean Germany or Argentina or India or Thailand, not necessarily, as I said, Italy. But let's say the analytics and AI population that is working on analytics and AI is growing across the group, thanks to the work that we have been doing and carrying on in the last 3 to 4 years. And we plan to keep growing this community. Now we have something around 250, 270 people across the group. But our target is to reach something like 400. So I guess that there will be space for those that are willing to relocate or not. As I said, that there might be positions in Generali Italia as well. By the way, we are having, I know that Generali Italia is a bit struggling in finding new data scientists, and they are also having establishing a liaison with University of Salerno. I guess Salerno, yes, if I'm not mistaken. It's either Naples or Salerno now, I can't remember. In any case, in Campania. And so because they are continuously looking for new profiles. So if you are interested, probably we can put you in contact with Generali Italia head, the HR people. And I stop here because I want to leave the space for the questions and remarks. Thank you. So
thank you for intervening. So yeah, let's go to the Q&A then. Okay, I just read the questions, but if you want, please feel free to unmute yourself to ask it. So don't worry. So the first from Lorenzo Randazzo. Cars could be very different. Are the models generalized for all cars? Example, identify doors of every car, or you first identify the car model and then you segment the parts? Interesting question.
I will go, Marta.
Yeah.
Okay. No, okay. We build a model that generalize all the components of the car. I mean, we are not filtering the by car model and then applying the image segmentation task, because this means that we need, I don't know, thousands of models, and this is not possible. So here the point is being smart enough in choosing the data inside the data set. And yeah, there's no concrete rule, but in our experience, if you are able to give enough information to the model in order to understand when you have front and back door or just a front door, the model is going to learn how to distinguish it. Then, yeah, obviously, maybe some little error will always be present, but yeah, and consider one more thing, because for example, if you are considering a van, in that case, we are not performing the image segmentation task. We have a filter at the beginning that is able to say, this is a car, this is a truck, this is a van, etc., etc. So we are performing this on cars.
Then, if I may add, in general, for any kind of models, this one or whatever other ones, generalization is always a challenge. So it's a critical point in any case, but we are trying to handle in that way, as Antonio explained right now.
Okay, thank you.
You're welcome.
Welcome.
Stop. So go to the next question from Cecco. Is it possible to share with us this notebook? So I think he's referring to the notebook used for Polimi, not the code, the source code, I think. So yeah.
Yeah. We if you want, we can share it. Obviously, not the models and not the images, or at least not the images belonging to the data set. But yeah, absolutely yes. Moreover, there are also links to the different kind of libraries. So if you would like to deep dive, then you are free to do that.
Yes, maybe
Okay,
if you are
thanks.
really interested, you can write directly us and you can share by mail.
Yeah, I think it would make sense to, you have the emails there, so everything it gets in the system, so nothing is done bad. And maybe also, yeah, so that you can exchange conversation, you have a question. I mean, it makes sense. Also, we can ask you later, and this video is recorded, so maybe with the recording, we'll put also a notebook. Can be idea. Cool. And some other questions. We have a couple of minutes before the ending. I would say not for now. So we also can end it a little earlier. So once again, thank you a lot, Antonio and Marta and Alessandra, for presenting this project to us. It was very exciting for me, and also I think also for all the audience, and for having further collaboration in the future then. Have a nice evening.
Thank you all.
Thank you.